Hello students, in last session the exercise 4.2 is completed. Now we see the next topic. In the exercise 4.2 there are two types of sum. One is find the roots using the factorization method, and second type is the practical sums are given and find the roots using again factorization method given in the question. Now another method to solve the quadratic equation, which is called completing the square method, on your page number 76 in your textbook. Solution of quadratic equation using completing the square method. Solution of the quadratic equation using the completing the square method. The name of method is completing the square method. In standard 8 we know how to find first term, middle term and the last term. From the first term, keep in mind three formulas. First term is equals to Ft, middle term in short Mt, and the last or third term which is Lt. You can also take as the third term T. Formulas: first term Ft is equals to square of middle term upon 4 multiply with the last term or a third term. Middle term is equals to plus or minus 2 multiply with square root of first term multiply with square root of last term. And the third term or last term is equals to square of middle term upon 4 multiply with first term. In the completing square method, the formula to find third term, which is very useful, square of middle term upon 4 multiply with the first term. There is no more theory for completing the square method. As we know, there are three types of roots of quadratic equation has. It has at most two roots. It divided into three parts, exactly 2, 1, or there are no real roots. Let's see three different types of examples regarding the completing square method from our textbook. Open your page number 80. Page number 80. The example number 7 is given. On page number 80, the example number 7 is given. Solve the equation given in example 3 by method of completing the square. In example number 3, open your example number 3. In the example number 3, the equation is given that 2x square minus 5x plus 3 is equals to 0. Right now we are solving example number 7, but equation taken from example number 3. Given equation 2x square minus 5x plus 3 is equals to 0. Before using the completing the square method, first of all, we would like to check it is a perfect square trinomial or not. No, it is not a perfect square trinomial. Now you able to find which one is perfect square trinomial or not. If it is perfect square trinomial, there is no need to find third term. First of all, find the third term using the given first term and the middle term. New third term. Third term is equals to square of middle term upon 4 multiply with the first term. Middle term is minus 5x whole square upon 4 multiply first term, which is 2x square. Minus 5x square, you can also write like this, 5x into 5x and square of minus will be plus, or 25x square also. Cut does not possible, then I will write here directly 8x square, x cut, and the answer is 25 upon 8. Keep in mind always the third term is the constant term. There is no variable in a third term. It is our new third term. Now start from the given equation. 2x square minus 5x plus 3 is equals to 0. Rest first two terms are as it is. Put new third term, old third term at fifth step. 25 upon 8 plus and the 25 upon 8 minus. Now plus 3 remains as it is equals to 0. Now take the LCM first. 8 2s are 16x square minus 8 5s are 40x plus 25 minus 25 plus 24 is equals to 0. 8 goes through the multiply with 0. Now put first 3 terms into the bracket. Minus 25 plus 24 minus 1 is equals to 0. 16x square minus 40x plus 25, it is a square of 4x minus 5 whole square. How it is possible? Square root of 16x square is 4x, square root of 25 is 5, and the sign of middle, which is minus. If we expand it, we get above term. Minus 1 is the square of 1 itself. Now we are using one identity to factorize a square minus b square. Into first bracket 4x minus 5 and 1, in another 4x minus 5 and 1, a square minus b square is equals to a minus b and a plus b. One time minus and the one time plus is equals to 0. That's why 4x minus 5 minus 1 minus 6, 4x minus 5 plus 1, which is minus 4, is equals to 0. On comparing both the bracket with 0. For x is equals to 6. That's why the value of x is equals to 6 upon 4. 2 3s are and 2 2s are. The value of x is 3 upon 2. Same way here, 4x is equals to 4. That's why x is equals to 4 upon 4. 4 cut and we get x is equals to 1. Here 3 upon 2 and 1 are the solution of equation. It is from our example number 3. The answer of example number 3 and the answer of example number 7 both are equal because the equations are same but method are different. Therefore, root or equation from the question solve means the solution 3 upon 2 and 1 are the solution of given equation. It is called completing the square method. Quite easy. Let's see next example number 8. Find the roots. See on your page number 81, the question is given. Find the roots of equation 5x square minus 6x minus 2 is equals to 0 by method of completing the square. First of all, we write the given equation. Given equation is 5x square minus 6x minus 2 is equals to 0. First of all, find the third term or the last term as you wish. Third term is equals to square of middle term upon 4 multiply with the first term. Middle term, here the middle term is minus 6x whole square upon 4 multiply with first term which is 5x square. Minus 6x square gives 6x into 6x upon 4 into 5 x square. X cut is possible. 2 2s are 2 3s are and 2 3s are. 3 3s are 9 upon 5 which is our required third term. Now as we know, what is our first step? First step is write the given equation. 5x square minus 6x minus 2 is equals to 0. 5x square minus 6x as it is. We substitute new third term which is plus 9 upon 5. Subtract it. First add then subtract, because the rule for a perfect square trinomial is first and last term are compulsory positive. So that first add then subtract. And again minus 2 remains as it is. Now take an LCM. 5 5s are 25x square. 6 5s are 30x plus 9 minus 9. 5 2s are 10 is equals to 0. Put first three terms into a single bracket. 25x square minus 30x plus 9. And the minus 19 is equals to 0. Addition of two constant terms. Now 25x square minus 30x plus 9 is the square of one binomial. Square root of 25x square is 5x. Square root of 3 which is 9 which is 3. Sign of middle which is minus whole square. Minus 19 is equals to 0. 19 is not a perfect square number, so that here we are taking forcefully square root of 19. Square root of 19 and the whole square gives 19. Same procedure will be repeated here. Again apply identity like this. Into a first bracket 5x minus 3 and root 19. In another 5x minus 3 root 19. One time minus and one time plus is equals to 0. The further simplification does not possible. That's why we compare both with 0, because it is rational plus irrational numbers. Or the second bracket. That's why 5x, shift these two terms left to right. 3 plus root 19 and we get x is equals to 3 plus root 19 upon 5. Same way here, 5x is equals to 3 minus root 19. That's why x is equals to 3 minus root 19 upon 5. Therefore, 3 plus root 19 upon 5 and 3 minus root 19 upon 5 are required solution of given equation. Using which method? Using the completing the square method. Here the two examples are completed. Now we see the next example 9. Let's see the next example number 9. Example number 9 is the most important example. On your page number 82, first of all see the question. Find the roots of 4x square plus 3x plus 5 is equals to 0 by the method of completing the square. First of all we need to write our given equation. given equation is 4x square plus 3x plus 5 is equals to 0. We are finding the roots of this equation using completing the square method. So that first of all, find third term is equals to square of middle term upon 4 multiply with the first term. Middle term is 3x square upon 4 multiply with first term. First term is 4x square. 3 3s are 9x square upon 4 4s are 16x square. X square cut and we get 9 upon 16. 9 upon 16, which is our new third term, given us the first 3 terms as a perfect square trinomial. Starting from the given equation, 4x square plus 3x plus 5 is equals to 0. That's why the 4x square plus 3x as it is plus substitute the new third term 9 upon 16. Subtract it 9 upon 16. First add then subtract, and plus 5 remains as it is. Now take LCM first. 16 4s are 64x square plus 48x plus 9 minus 9 plus 16 5s are 80 is equals to 0. Put first 3 terms into a single bracket. 64x square plus 48x plus 9 minus 9 plus 81, which is plus 71, is equals to 0. 64x square plus 48x plus 9 is the square of 8x plus 3 whole square. Plus 71 is equals to 0. If here is a negative sign, then further factorization is possible. Right now the factorization does not possible. That's why 8x plus 3 whole square is equals to minus 1. We know the square of any number doesn't negative. We know square of any number can't be negative. Whenever you see statement like this, right, this equation has no solution. Therefore, given equation has no roots. What is used? No real roots. The value of x are not possible to finding for this equation. There are no any value of x are possible. Let's see the next one. Here the example number 9 is completed. The new theory. 3 examples regarding the completing the square method. Now we discuss new theory. New theory is quadratic formula. Solution of quadratic equation using the quadratic formula. The quadratic formula is also called as Surendranagar's formula, because the concept is given by mathematician Surendranagar, so that it is also called as Surendranagar's formula, quadratic formula. To use the quadratic formula, first we find the discriminant. If ax square plus bx plus c is equals to 0, where a does not equals to 0, then discriminant, which is called d, discriminant which is called d is equals to b square minus 4ac. If we are applying formula to solution to find quadratic equation using the quadratic formula, first of all we would like to find discriminant of the given equation. Then we are applying quadratic formula. Now, the solution of quadratic equation using quadratic formula. X is the solution, minus b plus or minus square root of b square minus 4ac. See, b square minus 4ac is discriminant, not a square root. Square root is in formula upon 2a. It is called quadratic formula. Quadratic formula to find the roots of the equation. If we split as a 2, we get x is equals to minus b 1 time plus square root of b square minus 4ac upon 2a, or x is equals to minus b minus square root of b square minus 4ac upon 2a. Both the solutions are here. Now we see the next example using the quadratic formula, the solution of the equation. On page number 83, the example number 9. Example number 9 is completed. See example number 10 on your page number 83. Solve question number 2 first. Exercise 4.1 by using quadratic formula. Exercise 4.1. First of question 2. On page number 73, the area of rectangle plot is 528. The length of plot is 1 more than twice its breadth. We need to find the length and breadth of the plot. The first of all equation is obtained from the given situation. From exercise 4.1. Question number 2, the first equation is 2x square plus x minus 528 is equals to 0. Solve this equation using which method? Quadratic formula. The first of all, the coefficient of x square is 2, coefficient of x is 1, and the constant term which is 5 minus 521. First find discriminant. D is equals to b square minus 4ac. Then apply formula. B square square of 1 minus 4a is 2 and c is minus 528. 1 minus minus plus 4 to the 8 into 528. 1 plus 4 to 4 is equals to 4 to 5, which is D. Here D is greater than 0. It is depends on nature of roots. There are 3 different types of values of D are obtained. It is greater than 0. Then this equation has 2 distinct real roots. We see in next topic nature of roots. Now using quadratic formula, x is equals to minus b plus or minus square root of b square minus 4ac upon 2a minus where b is equals to 1 plus or minus square root of b square minus 4ac which is 4225 upon 2. Instead of a, the first term is equals to 2. Minus 1 plus or minus square root of 4225 which is 65 upon 2 to the 4. Therefore, by splitting x as a one time plus and one time minus, we get minus 1 plus 65 upon 4, or x is equals to minus 1 minus 65 upon 4. 64 upon 4, cut is possible. 16 4s are minus 66 upon 4 by 2, 2 2s are, and 33. The value of x is equals to 16, one is 16 and another is minus 33 upon 2. Here what is x? X is the breadth. X is the breadth. That's why negative does not possible, does not belongs to capital N. That's why it is not possible. Therefore, breadth of plot is equals to x is equals to 16. Unit is given, unit is meter, then here is the meter. Length of plot is equals to, the length of plot is 1 more than twice breadth, which is 2x plus 1. 2x is 16 plus 1, 32 plus 1, which is 33 meter. 16 multiply 33, length multiply breadth gives area. 528 is area. Yes, in the question 528 area is a given, hence it also verified that. Here the example number 10 is completed. Let's see the one new theory topic, nature of roots. Nature of roots is the topic of next to next exercise 4.5, but in this session we complete it first, because solutions are obtained or not, how to take decision the quadratic equation has a solution or not. Nature of roots for quadratic equation. We know ax square plus bx plus c is equals to 0 is the standard form of quadratic equation. Nature of roots is depend on the discriminant. Three types of nature of roots. First, if b square minus 4ac is greater than 0, then the roots of equation are real and distinct. Distinct means different. Second, if b square minus 4ac is equals to 0, then the roots of equation are real and equal, and that is x is equals to minus b upon 2a. Why? If we substitute here 0, both terms are 0, we get minus b upon 2a minus b upon 2a. Third one, if b square minus 4ac is less than 0, then what happened? Then the real roots of equations are not possible or not exist. There is no real roots exist whenever we get the value of discriminant b square minus 4ac is equals to 0. We see new two things in this topic. One is the quadratic formula and one is the completing the square method. Three methods are completed to finding the solution or roots of quadratic equation. First method is factorization method. Second method is the completing the square method. And third method is the quadratic formula. Mostest easy method is the quadratic formula and the factorization method. In the question, the name of method is not given, then we are using the factorization method. If you are not able to finding factors of the number, then use quadratic formula. It is very convenient, but there is a one problem to finding the square root. Whenever the number is larger, use chapter number 1 to find the square root, means the factorization, prime factorization. First of all, find the prime factors of the number, then make it into the pair and then find the square root of number. If number is smaller, then there is no problem. Then when the number is larger, there is too difficult to find the square root. Whenever we meet in next session, we will discuss our new examples. Try yourself to solve some numerics regarding the e-learning session and regarding your homework.